Hey guys, so today we are going to be in section 4 of chapter 3. So chapter 3, section 4, which is zeros of polynomial functions. We learned in 3.3 how to divide polynomial functions. And I said sometimes it's really nice when you get 0 because that gives you the solution to that polynomial function. And so today that's all we're going to be focused on is finding the zeros or the solutions to these polynomial functions. So before we do that, we're going to talk about the rational root theorem or the rational zero theorem. Some books say it one way or the other. This is one of those theorems that sounds really, really complicated when it's just written out like it is right there. But to use it, it's really not as bad as it sounds. So I'm going to read it, I'm going to talk about it, and then we're going to use it, and you'll see that it's not that bad. So it says if we have a polynomial function, that's what that f of x equals a to the n, blah, 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 blah. That's just the really general way of writing a polynomial function. So if we have a polynomial function that has integer coefficients, so that means all of the coefficients are whole numbers. And we know that we have a p divided by q, where p over q is reduced. And we know that that p over q is a rational zero of f. So we know that that's a solution to that polynomial function. If we know all of that information, then here's what we know from this theorem. We know that p then is a factor of the constant term and q is a factor of the leading coefficient. So what this is really used for is whenever we are looking at the zeros of a function, really every rational number is a possible answer, is a possible zero. And that's a lot to deal with. If you remember back in 3.3, when we did our synthetic division, if we didn't have a number to put in that box, we would just be guessing, right? We would just say, well, I guess I'll try 1 or I guess I'll try 2. They had to give us one of the solutions, or we had to know one of the solutions to put in that box in order to divide by it. Well, today we're not going to be given any solutions or any zeros. And so we would just have to randomly pick numbers, which is not time efficient or fun or anything. And so this rational root theorem allows us to go from infinite numbers that we could possibly put in that box to divide by, and it's going to take us down to a really finite number that's so much easier to handle. So here's basically what the rational root theorem says, that all possible rational zeros, that's zeros that can be written as a fraction, that are not imaginary, don't have square roots or anything like that, nice numbers, all rational zeros can be written or be found by looking at the factors of the constant term over the factors of the leading coefficient. And that's how we're going to utilize the rational root theorem for today. Okay, so let's go to the board and let me show you what we're talking about. Okay, because I said this is one of those theorems that sounds horrible and then it's actually not as bad to utilize. So here's our function. We have f of x equals negative x to the fourth plus 3x squared plus 4. And we want to list all possible zeros. Notice the word possible. That doesn't mean that it's all the zeros. That doesn't mean that everything we write down is actually a zero for this polynomial. It just means that all of the zeros that are rational for this polynomial will be in our list somewhere. Okay, so the first thing we want to look at is we want to look at the factors of the constant. That's what we want to look at first. So what is the constant? Well, the constant is the number tacked on at the end that doesn't have a variable with it. That is your constant. So our constant is 4. So we need to find the factors of 4. Well, what are factors? Factors mean what times what will give you 4. Well, 1 times 4 will give me 4, correct? But negative 1 times negative 4 also gives me positive 4, doesn't it? So the way we always write these whenever we're coming up with all these possibles is once you find one factor, you're going to put plus or minus. So it's not just 1, it's plus or minus 1. And it's not just 4, it's plus or minus 4. And it's not just 2, because 2 times 2 equals 4, but it's plus or minus 2. That's because the positives times positives will give you positive, and the negative times negatives will give you negative. So we have to include both the positive and the negative. Every single time you're writing down these factors, you're going to do plus or minus. Okay? So we're looking at the factors of the constant, and then we have to look at the factors of the leading coefficient, which I'm going to abbreviate LC from here on out. So what is the leading coefficient? Well, the leading coefficient is the number that is in front of the variable with the biggest exponent. In this case, our biggest exponent is x to the 4th. So the coefficient out front of that is a negative, which means our leading coefficient is -1. So what times what gives us -1? Well, it's a positive 1 times a -1. So it's just plus or minus 1. Okay, so the list of all of our possible zeros equals the constant, the factors of the constant, over the factors of the leading coefficient. And that was plus or minus 1, plus or minus 2, plus or minus 4, all over plus or minus 1. So that means all possible zeros for this function are plus or minus 1, plus or minus 2, and plus or minus 4. Because dividing by that 1 isn't going to change anything. And so we just went from infinite solutions down to 6. If we had to actually find the zeros, the rational zeros for this polynomial, now we would have 6 choices to put in our little box when we did synthetic division. So that's pretty good to go from infinite down to 6. That one was a little bit easy because we divided by 1. So let's do one where we're not going to divide by 1 so you can see all the other possible ways we get solutions like this, okay? So for B, we have f of x equals 15x to the 3rd plus 14x squared minus 3x minus 2. So again, we want to look at the factors of the constant. We want to look at that first. Well, what is the constant? The constant is 2. So we're actually going to luck out there because what times what gives you 2? Well, 1 and 2. So we put plus or minus 1 and plus or minus 2. Now, what about the leading coefficient? What is the leading coefficient? Well, in this case, it's 15. So we're going to have quite a few things for that because we have plus or minus 1 and plus or minus 15, and then plus or minus 3 and plus or minus 5. Okay. So then the list of all of our possible rational zeros are going to be our constants over our leading coefficient. So this is how I systematically go through so I don't miss any of my zeros. Because when I have 1 and 2, that's going to be over 1 and 15 and 3 and 5, it's easy to get lost and forget one of them or lose it. So this is how I always approach it. I know I'm going to have to put this plus or minus 1 over each of these terms in my denominator. So I'm going to do that. Plus or minus 1 over plus or minus 1 will give me plus or minus 1. Plus or minus 1 over 15 is going to give me plus or minus 1 over 15. Plus or minus 1 over 3 will give me plus or minus 1 over 3, which is plus or minus a third. Plus or minus 1 over 5 will give me plus or minus 1/5. Now I have stuck that 1 over every term in my denominator, so I'm done with that one. I can kind of ignore it because I've applied it to all of my denominators. And I do the exact same process now for my 2. 2 over 1 will give me plus or minus 2. 2 over 15 will give me plus or minus 2 over 15. 2 over 3 will give me plus or minus 2/3. And 2 over 5 will give me plus or minus 2/5. So I get a lot more options on this problem, like a lot more possible zeros than I did on the first problem. But even with all these, that's 16 possible solutions. 16 solutions is a lot better to handle than infinite solutions. So I do recommend just going step by step and doing it that way. Notice I even did it kind of in rows to where everything in this top row has a 1 on top and everything in this bottom row has a 2 on top. That way I don't get confused, because sometimes you might have 32 possible zeros, but you can still keep track of all of them, okay? Most of the time you don't have that many, but it's nice to know that you can keep track of them. Leading, or it's constant over leading coefficient. That's how you find all your possible zeros, okay? So let's look at this. So how do we find all the actual zeros? These were all the possible zeros. That doesn't mean all of those were actually solutions to those polynomials. Some of those aren't going to be solutions. Well, if you want to find all the real zeros, all the rational zeros, the ones that are actually solutions, then what you're going to do is you're going to use that rational zero or rational root theorem to list all of the possible zeros. So you're going to do all of this so that we have a list of zeros. Then we're going to use synthetic division to actually find one actual zero. So we're going to pick from these possible zeros and divide our polynomial by one of those until we get a remainder of 0. As soon as you get a remainder of 0, you know that that is a 0 for that polynomial, and thus then after that you'll be able to either factor or use the quadratic formula or something like that, which is step 3. Step 3 is to factor or use the quadratic formula to solve for the remaining zeros. So let's find all of the zeros for x to the third plus 2x squared minus 5x minus 6. First step is we're going to use the rational zero theorem or the rational root theorem in order to find all the possible zeros. So that is going to be the constant over the leading coefficient. Well, the constant in this case is 6. So factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And what is my leading coefficient in this case? It's just 1. So that's plus or minus 1. So that means my list of possible zeros is just plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So that was nice. Our leading coefficient being 1 made it really, really nice. So this is going to be the list that I choose from to do my synthetic division. So remember, synthetic division, you start it the same way. You make a box, and then I'm going to put my coefficients in descending order from my polynomial. I have a 1, a 2, a negative 5, and a negative 6. I have my arrow and my bar, and I bring down my 1. That's how I'm going to start it. Now, I have 8 options to pick from to find a possible 0. So let's start with 1. Let's see if 1 works. I'm just going to start with a positive number. 1 times 1 is 1. You add down, which is 3. 1 times 3 is 3. You add down, which is negative 2. 1 times negative 2 is negative 2, and you add down. Did I get a 0 in my remainder spot? I didn't. I got a negative 8. That means that this is not a 0 because you need to get a 0 there. So I'm going to erase. If you did it with pen, you can erase. As in, like if you made this in pen, you can erase those other numbers. So positive 1 is not a solution. It's not a 0. So let's try 2. 2 times 1 is 2. Add down, that gives me 4. 2 times 4 is 8. Add down, that gives me 3. 2 times 3 is 6. Add down, and that gives me 0. Yay. So 2 is a 0. That is a solution. So that's great. So over here, I'm going to write the original x to the third plus 2x squared minus 5x minus 6 equals 0. what we just found out, oops, you can't see that. Sorry, let me slide it down. What we just found out was that 2 was a 0 or a solution. So remember from 3.3, we can write that as x minus 2. Because if we set that term equal to 0, we say that x equals 2. So that works. And then from our synthetic division, we know that it's this times what we just found in our synthetic division. We started with x to the third and divided by x. So it gives me x squared plus 4x plus 3 equals 0. Remembering that these are the coefficients to my x's and my x squares. Now, step 3 says I need to factor or use the quadratic formula to solve for my remaining zeros from this quadratic. So I'm going to try and factor. I think this one's going to probably play nice. It's x squared, so that's x and x. This is positive, so that tells me both signs are the same. And this one tells me both signs are positive. I need factors of 3 that add up to 4. Well, the only factors of 3 are 1 and 3. Do they add up to 4? Yes, they do. So I put 1 and 3. So now I would set each of these terms equal to 0 to solve for my x. So x minus 2 equals 0, x plus 1 equals 0, and x plus 3 equals 0. So x equals 2, x equals negative 1, x equals negative 3. A lot of times you're going to have a solution set for these where it'll say zeros and then you have curly brackets and you put in your zeros with commas. Negative 3, negative 1, and 2. I wrote mine in ascending order. It would not matter though, either way. But notice all of our answers were rational. We got nice numbers, whole numbers. And notice all of our answers, negative 3, negative 1, and 2, were all listed in our possible zeros over here. And that's how it will work if all of your answers are rational answers. Now, not every time are you going to get rational answers. Sometimes you get irrational answers. Those are answers that have square roots in them and things like that. Sometimes you could even get complex answers. Complex answers have I. That's your imaginary units. Those are not necessarily fun, but they're not wrong. You still do the process the exact same way, and you start with finding a rational zero first, and then you move on from there. So this one was our nice one because all of our answers were rational, and all of our answers, because they were rational, were part of our possible zeros. Negative 3 was a solution, negative 1 was a solution, and 2 was a solution. If we would have plugged negative 1 or negative 3 up here instead of 2, like if we guessed that way, we still would have gotten 0 here, and we would have factored it, and it would have worked the same way. So let's go do one that maybe isn't quite as friendly. Okay. We are going to find all of the zeros for f of x equals x to the third plus 7x squared plus 11x minus 3. First step is the rational root theorem, where we look at the constant over the leading coefficient. The constant in this case is 3, so that's plus or minus 1, plus or minus 3. And our leading coefficient is just 1. So all of our possible zeros are plus or minus 1, plus or minus 3. So that is really nice. So that's only 4 options then to plug in to our synthetic division. So there's only 4 that we have to choose from. So we like that. That's definitely nice. So let's set up our synthetic division. And I'm going to do it just like I did last time, where if we get one that doesn't work, I'm just going to erase it. You can do that, or not, it's up to you. All right, so there's our synthetic division with coefficients 1, 7, 11, and negative 3. And now I just pick. I have to see if I can find a 0. So let's try 1. 1 times 1 is 1, add down. 1 times 8 is 8, add down, that's 19. 1 times 19 is 19, add down, and I get 16. Well, that's not 0, which is what I want, so 1 was not a solution. Okay. Well, let's try negative 1. Let's just see if we can get that. Negative 1 times 1 is negative 1, add down. Negative 1 times 6 is negative 6, add down. Negative 1 times 5 is negative 5, add down. And I get negative 8. Again, I didn't get 0, so negative 1 is not a solution. All right, well, we've gone through half of our answers. Let's see if we can keep going. What about 3? 3 times 1 is 3, add down. 3 times 10 is 30. That's not looking good. Add down, so now we have 41. 41 times 3 is 123. Add down, I get 120. Well, that's definitely not 0, so that doesn't work. I wonder if we have any zeros. We only have one option left, which is negative 3. That's our last choice to try and find a rational 0. So negative 3 times 1 is negative 3. Add down. Negative 3 times 4 is negative 12. Add down. Negative 3 times negative 1 is 3. Add down. Whew. Well, that's good. We finally found one. So we started with x to the third plus 7x squared plus 11x minus 3 equals 0. There you go. We found that negative 3 was a solution, which means x plus 3 is a factor. And our other factor is x squared plus 4x minus 1 equals 0. We know that because this is the coefficient. We started with x to the third divided by x. So then we put x squared, x, and then that's our constant. But here's the thing. We used all of our possible zeros trying to find a solution. Negative 3 was the last one we had. So there are no other rational zeros or rational solutions. So when there's no other rational solutions, or when you look at this and you say, okay, if I factor that, what are factors of 1 that add together to give me 4? There aren't any, because the only factors of 1 are 1 and 1. And if you add those together, you get 2. And if you subtract them, you get 0. There's no way to get 4. So when you get to that point, that's when you have to use your quadratic formula in order to solve. So we need to solve this x squared plus 4x minus 1 equals 0 using the quadratic formula. So our a in this case is 1, our b is 4, and our c is negative 1. Remember, your quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So negative b, negative 4, plus or minus the square root of b squared, 4 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. Now we're going to work on simplifying this. Negative 4 plus or minus 16 plus 4 all over 2. Negative 4 plus or minus the square root of 20 all over 2. Well, the square root of 20 can be written as the square root of 4 times 5 all over 2. Square root of 4 is 2, so bring that out front. So you have negative 4 plus or minus 2 square roots of 5 over 2, which reduces down to negative 2 plus or minus the square root of 5. Let me slide you over because I know you ran off the screen. So that means my zeros in this case are -3, because we found that using synthetic division. That was our one rational zero. -2 plus square root is 5. And -2 minus square root is 5. Remember, the program does not like it if you use plus or minus, so don't include the plus or minus. Separate them out on the final and on chapter test so that you write for me. I don't mind if you use plus or minus there. But this is what happens whenever we run out of rational zeros to try and work with, or we get to a quadratic that's not going to give us a rational answer. Sometimes you're going to get irrational answers, and that is okay. You still keep working it the same way. Let's do another one. We're going to find all of the zeros for x to the third plus x squared minus 5x minus 2. Using the rational root theorem, you're going to look at the constant over your leading coefficient. Your constant in this case is 2. So factors are 2 plus or minus 1 plus or minus 2. Your factors of the leading coefficient is just 1, so it's plus or minus 1. So again, we're looking out with a nice short list of possible rational zeros. Just plus or minus 1 and plus or minus 2. So we're going to do synthetic division. 1, 1, -5, -2. Let's try 1. 1 times 1 is 1, which is 2. 1 times 2 is 2. -3. 1 times -3 is -3, which is -5. Well, that didn't work. Let's try positive 2. 2 times 1 is 2, add down. 2 times 3 is 6, add down. 2 times 1 is 2, add down. Yay! So what that means is we had x to the third plus x squared minus 5x minus 2 equals 0. We found that 2 is a factor, so that's x minus 2 is a factor. And then from our synthetic division, we know that x squared plus 3x plus 1 is the other factor that we need to solve. Again, if we look at this, if we were trying to factor it, we have 1 right here at the end. The only factor of 1 is 1 times 1. That will never add up to 3. That means we're not going to get rational zeros from this. So we need to use the quadratic formula in order to solve for this. So x squared plus 3x plus 1 equals 0. My a is 1, my b is 3, and my c is 1. So x equals -b, -3, plus or minus b squared. So I'm just going to say 9. I'm going to skip some steps. B squared minus 4 times a times c all over 2 times a, -3 plus or minus the square root of 5 all over 2. That can't be simplified any further. So my list of all zeros is 2, -3 plus square root of 5 over 2, and -3 minus square root of 5 all over 2. Sometimes you can't simplify it out as far as we could the first time. And so that is all of our these are all of our zeros for this function. We had 1 rational and we had 2 irrational, and that is okay. And that is the end of 3.4.